Why this webinar? First of all, I want to keep the paper industry and the paper product relevant for the future. I mean, it's a beautiful, sustainable product, but as we know, it's also a competitive world. Printing grades have taken a serious blow by digital media. And who knows what will happen to our industry if bioplastics get cheap and threaten paper as a packaging material. And maybe you didn't realize, but these Japanese toilets, you know, with a one small shower inside, they're already quite popular in hospitals for the elderly and the physically handicapped. So even the future of tissue paper might not be as safe as we think right now. We therefore are obliged to continuously improve the paper making process, and we must look at all the possibilities to produce better and/or cheaper paper. And machine clothing is just the shackle in the chain where I focus on. At the moment, I feel that quite a few paper makers leave the optimization of paper machine clothing a little bit too much to their suppliers. I have had my own experience where a paper maker once said that if the supplier makes sure that the machine is up and running, he would place the orders. No challenging goals, no real improvements, but just a reward to maintain the status quo. And that's not really what I would like to see, because that is not our ticket for the future. So my personal goal is to drive the innovation in paper machine clothing. The suppliers must develop innovative new fabrics and felts, but they also need the paper makers that are willing to do, they need paper makers that are willing to do trials, take a little risk, and support the suppliers with fact-based feedback on their product's performance. So what I hope to achieve is that one day paper makers will be comfortable enough to just as easily try a new felt or a new supplier as they do now trying to new tires on their car. But I guess that will be someday far in the future. First, we'll start with the structurally improving part in cooperation with your suppliers. Why is paper machine clothing or optimizing paper machine clothing complicated? Well, I think it's not really that complicated, but it's surely considered complicated. And that is probably because, well, felts, fabrics, they are complicated products, especially press felts. I mean, a supplier must select the right felt design for you, where he can choose from about 100 million theoretical variants. That is a hell of a job. Then machine clothing itself is just one of the many variables in the machines. Sometimes it's really hard to differentiate the effects of all these individual variables. And talking about variables, machine clothing is a true variable. Not only from piece to piece there is a variance, also over the lifetime, the properties and the behavior of a piece of felt will vary. From all the mechanical parts in your machine clothing is probably the one that changes most during its few weeks of life in your machine. Just some examples. While a forming fabric wears down, its dewatering capacity can change in both directions, more or less. Most fabrics elongate a bit, and sometimes more than a bit, which can be one of the reasons for a poor cross-machine sheet profile. Especially the properties of press felts change over time. A certain amount of compaction is good for dewatering, but a certain level turns out to be bad. And while the felt is wearing, it can affect your sheet properties, you have rewetting, moisture profiles, shadow marking, base marking, etc., etc., etc. So challenges enough. Now, how to deal with them? First of all, The supplier is and will always be the expert on paper machine clothing. Let him do the thinking, the designing. That's his job, or her job for that matter. In my opinion, the most important role of the paper maker is to judge the results. And like a true judge, the verdict must not be influenced by good relationships. A true and honest verdict is based on facts. And then it becomes a little bit more complicated because it may not be clear which facts are really that relevant. Obviously, in a technical environment like ours, facts are basically data. But we have a big machine and we have even bigger amounts of data. So to judge the performance of felts and fabrics, we need two types of data. We need data from the whole machine, input and output, which I call the overall machine data. And we need specifics on the felts and fabrics that are in the machine to follow how they change over time. The overall machine data we will use, the overall machine data we will use has to function as a total performance indicator, total machine performance indicator. Of course, one individual fabric or felt is not solely responsible for your production high and lows. On the other hand, a paper machine is a complex system. A change here can have very unexpected consequences somewhere else. Therefore, it is always important to look at the outcome of the total system. So we're looking for machine performance indicators that have a certain relation to paper machine clothing. And the first and most important thing is that it must be per ton or per day. Whatever we measure, you must be able to measure it in per ton or per day. Things like a headbox flow or amps to a motor, they are not suitable. Of course, the ultimate indicator is the output, production, tons per day. You can vary a bit with that, like total production or sellable paper or A quality or whatever, but tons per day must be there. Additionally, you can think of other metrics that influence your cost price or paper quality. Things like expensive chemicals or runnability issues, like the number of breaks. Of course, the number of breaks also affects your production or your output. But they also may have an influence on the necessary headcount on the machine. So it's worthwhile to monitor that separately. And there might be other things that are important for your mill or for your circumstances. Just as an example, electric power consumption for vacuum drives could be one, or steam consumption in pre-dryer section. Whatever is relevant for you, you can use it, as long as it's per ton or per day. Now that we have several data points per day or per ton, if it's per ton, by the way, you can easily convert it to the consumption per day. We can combine that data beautifully with our felts and fabrics, because our felts and fabrics go in on day 1 and go out on day X. So if we combine those data, we can easily say that this or that felt or fabric produced so many tons per day, and it consumed so many gallons of this or that, in average had so many breaks per day. Like I said before, with these data points, you cannot judge the performance of a single felt or fabric, but it does tell you something about the impact of that individual product on the whole machine. So We know the forming fabrics and even more the press felts change over the course of a couple of weeks. And usually these changes follow a trend. But not all paper makers know how these trends look like for their machine, for their position. So start to measure a limited number of properties, but do it every day. For those of you who have seen my presentation or read my white paper, No Risk, No Future, which is about doing trials with paper machine clothing, you know that it is also an option to only collect the data on the moments that your machine is running well. In that case, your operators have the time to do these measurements, and you are basically building a data set of your perfect machine. So it's up to you. I mean, measure everything, good and bad days, or just measure the good days. It's both workable as long as you stay consequent. For forming fabrics, you could simply measure the thickness or caliper every day. And if you take that as a percentage of the original caliper, you can easily do some trials with thicker or thinner fabrics and still easily compare the wear trend over time. The same applies for press felts. You could measure the felt caliper daily as a number, as in mils or millimeters, but it's smarter to make it relative by calculating the compaction of a felt. This is quite an easy calculation, which I will explain a little later in the presentation. And of course, permeability, same story. It's a very important variable in your process, the felt permeability. And it's quite easy to daily measure the airflow through the felt, but it's even better to make it relative to the applied vacuum in the Euler box. And finally, tension is an important and very often underrated parameter, especially for forming fabrics. And this will be discussed in more detail in the tips and tricks session of this presentation. Now that you have collected your machine data per day and you measured your PMC properties per day, you can combine that information with the dates on and off of your felts and fabrics. In this example, you see a table, example table. You see that on January 6th, the bottom fabric was 6 days in the machine, the pickup felt was in its 34th day, and during that day there was one wet end break and the machine produced 100 ton. For simplicity, during this presentation, I have only included two machine performance indicators, no machine clothing specific data. But obviously, this table should contain much more columns with much more data. Then, over the course of a year, there will be several occasions where the bottom fabric was in its 6th day. So we can average all those similar data for the 6th day. And not only for the bottom fabric, but all important machine clothing positions. So after a while, you have trend lines over the lifetime for each of your positions. I see one answer, one question, I mean the bottom fabric. So top forming fabric, bottom fabric. PU is pickup felt. Just an example of one piece of machine clothing in your machine. What you get is your trend curves. And you could build a chart like this. On the horizontal axis, you see the running days from day 1 until the last running day, or the average last running day. And on the y-axis, your data will be presented. And this is a fake example of a pickup felt. And if you look at the trend curve for the daily production, you can clearly see that the pickup position has quite an influence on the total output of the machine. For example, the break-in period on the left-hand side of the felt is clearly visible in the total output of the machine, just as the lacking of performance at the end of the felt life. Now include some other data like, oops, that was a bit fast, like the felt compaction or power consumption or whatever you wanted to measure for this position. This is your normal, and with these data, both you and your supplier can much easier see what a trial felt or fabric is doing. It puts things into perspective. So we are running a trial now, and we see how it develops over time. You see that, for example, in this first days of the trial felt, the output of the machine, the red dots, are a little bit higher than usual. It's also noticeable that the felt compaction, the light blue line, is much lower than usual. And the dynamic felt permeability is also a little bit lower than usual, which combines nicely with the higher compaction. With this information for the felt supplier, it is this information is essentially actually for the felt supplier to adjust his designs and make better fabrics or felts. And you as a paper maker can gain much better quality data than the felt supplier who visits your mill once every week or every month or whatever. You take care of the data, and the felt supplier or fabric supplier takes care of the development of the new product.